traveling to the moon, in search for some new information. But I'm not coming alone. Come on, Fido. Ruff. We will be traveling through the Milky Way and into the distant galaxies. Now come along to join us in this episode. Ready to begin the mission? Fido, start the button. Mark. Boop. Here we go. Hey, look, I see a star, and another one, and another one, and another one. You know what these stars remind me of, Fido? Earth. The stars at night are big and bright, deep in the heart of Texas. Actually, Fido, stars aren't born like us. Come with me, and I'll show you the way. Actually, Fido, they all start at the stellar nursery and soon take their own path. For sun-like stars, they form into red giants, then to a planetary nebula, later a white dwarf, and ending with a black hole. While huge and giant stars almost take the same cycle, they form into red supergiants, later into supernova, and soon take their own path. The huge stars become neutron stars, and giant stars become black holes. But before stars can die out, they are placed in the HR diagram, which is a scatter graph of stars showing the relationships between the star's temperature and luminosity, also known as the Hertzsprung-Russell diagram.
Mark!
Wasn't it so cool? Wait, where are you going? Wait, don't tell me. Are you going to go watch Star Trek without me? We can't travel quick like them because Star Trek travels in light years. Duh. Well, light year is the fastest thing known to mankind. It can travel 186,000 miles or 300,000 kilometers per second in empty space. To get the idea of how fast this is, light can travel about 7 times around Earth in 1 second. Earth? I know, I'm impressive, right? Well, and you thought you can chase your tail faster than anything. Earth. What's going on? Okay, Fido, go check the control room. We'll be right back. Okay, everyone, it's all good. We're all doing fine. Fido is just fixing the buttons. But in the meanwhile, why not take a trip to the galaxies? Come on, Fido, let's go. Here's our first destination, the spiral galaxy. Spiral galaxies look like spirals with long arms winding toward a bright bulge at the center. Attractive, isn't it? Anyway, let's keep on going. Next up is the elliptical galaxies. They are shaped like ellipses or stretched circles. There's very little new star formation in these galaxies. No, Fido, you can't be there. We have to go to our next stop. Last but not least, presenting the irregular galaxies. These galaxies have little symmetry in their structure and are termed irregular galaxies. Get it? Because termed and term is irregular galaxies? Fine, we can go. But you can't go in my shoes. Well, wasn't that a rush? But you know, it didn't all magically happen like this. The universe was forced to take on the properties of an infinite phenomenon, processing the history and a beginning. About 15 billion years ago, a tremendous explosion started the expansion of the universe. We may not know if it's real or not, but it's a theory. That's right. This theory is known as the Big Bang Theory. Not the show, but the real Big Bang Theory. I know it takes so long to travel to the moon, but it's worth it. Hey, why don't you check outside for some fun? Hey, you're right. These stars do look like rainbows. Rainbows remind me of the electromagnetic spectrum. No, silly. The electromagnetic spectrum describes all the wavelengths of light, from dark nebula to exploding stars. It reveals an otherwise invisible universe. It truly is amazing. Oh my gosh, look, the moon. We did it, Fido. Looks like when you were fixing the buttons in the control room, you triggered something for the ship to go faster than the speed of light. Burf, come on, the moon we go. Ah, the moon. Well, as Neil Armstrong once said, one small step for man, one giant leap for mankind. Well, thanks for everything, you guys. See you next time.